Good morning all, and welcome to Drupal GoCon session on deployment made easy. This is Hunde, Keba, and I'm Ashish Pagar. We are presenting on behalf of DS Federal. We work for, thank you. We work for DS Federal, which provides solutions for federal government agencies, and we work with multiple agencies and create web solutions like blogs, sites, Drupal applications, and other research solutions. We Let me just make it a little bit bigger. Our technology solutions connect our customers to the people they serve. As we are we are broken down into small teams, and we work with different agencies, and we swap developers time to time. Thus, it gets difficult for us to manage our projects and set up hosting and set up deployments for different web solutions, especially Drupal. We have faced issues where we start to, where to start, how to set up optimized workflow for easier for the ease of for the developers, and how to optimize our deployments. Today we will try to show you how to make deployments easy for any Drupal solutions or just in any solutions in general. So there are multiple ways to deploy a project and set up a deployment solution, but it is easy. But it is important to identify your constraints and your needs. For example, any project, you will have a budget which you have to keep it as small as possible. You have to make sure that your team size is comfortable with it, with any solutions that you provide. And also the time is more important, because we want to churn out big projects as quickly as possible. So in this scenario, it's easier for us to have a standardized solution for deployment, which will help our stakeholders, in our case, to get their solutions ready as soon as possible. So it's easier for a single developer to set up the solution because it's organized in one person's brain. But when you're working in a team, even if it's a small team, it becomes a chaos. To deploy, how to set up your code, how to set up hosting. We will try to see if we can provide easier solutions with our methods. For our setup, we will try to see what solutions that we already have available. We have a classic local development for a single developer or a team of developers, and then you can set up either virtual machines and then deploy your solutions to your hosting facility and transfer it there. Let's talk about classic development. Classic development has. It's really good to have everything on your host machines and work it from there. It's because it's your machine, you can customize it, and it becomes a little bit difficult when you are sharing it with somebody. So we do have problems with local environments where sharing is of your application or your configurations is difficult. In that scenario, we need to have another solution. Also, with classic development, deployment is an issue because you have to go through multiple steps, taking your code from a local machine to a repository, and from there it will go to your server where it is hosted. The second solution for your local development is setting up virtual machines. Virtual machines are convenient way because you get your host application right there and you can customize it however you want. But The biggest con with local virtual machines is their size, and you cannot use, like, even the pros or multiple VMs, you cannot set up on your local development multiple VMs. It will take up all your resources. And even if you can share the images between your developers, it's still a huge image to transfer between two developers, and it's inconvenient. So in that case, like for our deployment solution, we start with local development, and we start with like some easier solutions like Docker. And it has come to our rescue multiple times, and we'll see like why Docker is really a good solution for us. So Docker is an open platform for developing and shipping and running applications. It allows you to package your application with all of its dependencies into a standardized unit for software development called or containers. So what is container? Containers, actually before that, let's talk about why we need like Docker and why is it so good. It's lightweight. It is specifically compared to VM environments where you need a whole separate OS. With Docker containers, you share the underlying resources of the Docker host, and you build an image that is exactly what you need. So you're basically running a process into one. You're just running one process on a host. So Docker helps with that. It is portable. The image sizes for Docker are very small, and you can inherit other images or other Docker images for your application. Also with Docker, you have consistent environment because all we are sharing in an image is just like your consistent configurations between all the images. So because of that, you will never have to worry about like having different settings on your PHP applications or on your web server or your MySQL database. So imagine like Docker as like or Docker container as like an apartment in a building. So in our case, like you can see from the image, it's like stacks from Ready Player One with just like shipping containers or containers just like stacked on top of each other. Then we talk about what is Docker container. Docker container is basically a capsule where your process will run, and it integrates everything that you require to run that process. And it's built by using an image, or basically like it runs an image inside it. So what is an image now? With an image, actually Docker image is just basically, it maintains, it's a binary package with all your root file systems, and it also includes metadata like your application process, like what ports that you're going to expose, any volumes that you're going to attach. The good thing about volumes is that you will have persistent data, so like you don't have to like create a spin up, or like it makes it easier to like have your data available on any environment, even if it's like you're sharing application or processes between each other. Now let's see how we can create a Docker image. So basically Docker image is created using a Docker file. So Docker file is nothing but like a list of commands. So it's like config file in Drupal, your Drupal application. It's just like some set of settings that you run inside a container. So in here, there's an example here where like images can inherit from other images, so you don't have to write a lot of code inside that Docker file. So for example, PHP 5.6 FPM inherits Debian Jessie. So like you can change, it's basically the OS that it's running on. You can change into Ubuntu, or you can change it to something else. So let's see example of a Docker file. So on the left side here, we have a Docker image for Drupal for Apache application, where we are inheriting from Ubuntu at the third line from the top. And then next line is actually we are running to install Apache. This is like set of commands that you can run on your terminal. So it's, the Docker file basically is, like I said, it's a sequential list of all the commands. Then we are setting up some environment variables with the env keyword. We are exposing port 80, and then at the end we are saying that we are running Apache 2 as our foreground service or a process. So this is a complete set of a Docker file along with the image of OS. But on the right side, you can see we are inheriting a Docker image created by a contributed or users who are contributed to Docker Hub. So we are just pulling it from PHP 7.2 Apache, and we are just setting up our work directory as HTML, or we can set it up anything. And then we are exposing the port 80 for our purposes. So when we run this set of command, it will spin up Apache application along with giving you access to the directory for loading your web HTML code basically, or we can load up like a PHP application or Drupal, which we all like here. So let's talk about like setting up the local, and Hunde will start or will show you how to set up your local and like take you through the whole process of deployment. It includes setting up after setting up local, setting up your CI or continuous integration, your hosting, and then quick demo for that. Hunde, up to you.
Thank you, Ashish. So first, because we jump in to discuss our continuous integration using Jenkins, so to just give you the bigger picture, what we are going to use is we are going to use GitHub as our repository. Like, we are going to store a repository on GitHub, and we will be using Jenkins as our build server, and we will be deploying our code to an EC2 instance. So that's our workflow. Like, we have our local environment, and we have Jenkins in the middle as our build server, and we're deploying codes to an EC2 instance. That's the entire idea of the workflow that we are going to present today. But before we do that, let's try to explain how our local environment looks like, because that's where we start. So everybody wants to have a similar local environment. Whether you have 10 developers in your team or you have only 2 or 3 developers, you just need to have the same local environment so that you won't be running into an issue when it comes to deployment and integration. So let's start first configuring our local environment. So for our local, I'm going to explain our major components on our local environment. That's starting with Dockerfile. So Dockerfile. So first we will have 2 containers in our local environment. One is for our web server. Our web server will have we will have a container for our web server. That's the first thing that we are going to do. And for the second part, we will have a container for our MySQL database. That's like the 2 containers that we need for our local environment. So we are building our local environment, our web server image from a Docker file. As Ashish explained earlier, Docker file is just a set of commands to build a container, and we have a Docker file in our local environment, which we are going to make public at the end of this presentation. Our repo will be public, and you guys can go in and check it out. So we have a Docker file that builds a web server using PHP 7.1 and Apache. But on top of that, what we did is, like, because this is specifically for Drupal, we have added Drush and Composer as an additional layer to our web server. So we don't have another container for Drush and different container for Composer as well. We just have one web server, and on that web server we are adding a layer for Drush and adding a layer for Composer as well. So to just show you quickly how our Docker file looks, what our Docker file looks like. I'm not sure why this is not picking up.
Come to the bottom. And then exit.
So this is generally our Docker file for our web server. As you can see, we are pulling image from PHP 7.1 Apache. This is contributed image on Docker Hub. We're just getting the image directly from there. And we have a couple of commands here where we are enabling some extensions and adding some extension for Drupal to run with our Apache. But what we did to the default images, we added another layer down here for this one. This is a layer for Drush. We're downloading Drush using from GitHub, and the next one is we're downloading Composer on our web server image. So our web server container will have Apache, PHP, Drush, and Composer in it. So we can use Composer from our web server, and we can use Composer from Drush from our web server. So that's how we did it. So something that was noted here is you can have a separate container for Drush, like you can have different container for Composer as well. That's possible, but we kind of find it like the way we did it is like we added another layer on our web server container. So that's this is how our Docker file looks like. And the next major component that we have here is Docker Compose. So Docker file we use to build one image, like one container to spin up. If we want to spin up one container, we use Docker file. But what if we have multiple containers that we want to spin up just using one command? In that case, Docker provides a solution using Docker Compose. So you can define multiple services using Docker Compose YAML file, and you can spin those services at a time just using one command. So if we want to just build one container, we can directly use a Docker file and use Docker run using Docker file. That will spin up one container. But if we want to have multiple services like web server and database and some other microservices, where we use Docker Compose. Docker Compose will give us the ability to put those in one file and spin them up at a time. So we have a compose file on our local environment, which we are spinning two services on. One is MySQL, and the second one is our web server. So for MySQL, we are just directly using the official image of MySQL 5.7. But for our web server, we are using our Docker file that I showed you earlier. So our Docker Compose file looks like this. Again, to just give you a highlight. So this is how our Docker Compose file looks like. Right? As you can see, we are defining two services here. One is for MySQL, and the other one is for Drupal site, which is our web server. So for MySQL, we are using.
No, it's not
work. So as you can see, we have two services defined here. One is for MySQL. This is our database container, and the second one is our web server container. So we are defining two services on our Docker Compose file, and when we run Docker Compose, it will spin up two services, one for our web server, one for our PHP Apache container. So there are a couple of things that we're configuring on each container. As you can see, we have environmental variables here, and I'm going to describe those on the next slide. But we are defining environmental variables. We're defining a volume. So those two are the major components as well. Like we consider those to be major components. So, and the next thing that we have is volumes. So volumes are preferred mechanism to have a persistent data, because so one thing that you need to know is like when the container is running, any data that the container produced, like whether it's a file or a database change, will be lost when we rebuild the container. So let's say we have a Drupal site running in our container, and we add a content type, and we add a content, and we rebuild the container. When we rebuild the container will lose that data that was created during the previous runtime. So if you have any data that you want to persist, whether the container is stopped or running, we use volume. So volumes are a way to persist data, and we mount the data on our host machine from the container. And when the container is stopped, the data will be lost from the container, but we still have it mapped on our host machine. When next time when the container tries to rebuild, it will check that there is a volume mounted, and it will take the data from the volume. So that's a way how we persist. That's a way to persist data from a container. So we have a couple of volumes defined here. We have one volume for DB backup. This is just generally for DB backup. If you are doing MySQL export, you can store the data here. And the second one is DB data. So DB data is where, as you can see, we are mounting the entire MySQL database directory on DB data. The reason that we're doing this is not part of our repo because it will be crazy, like it will be really big if we make it part of our repository. But we're just making sure that if the container in any case stops, so that we don't lose our data, we're just mounting the entire MySQL directory to a volume. So next time when we rebuild the container will have the data, the change that we made on our MySQL. So that's why we're mounting the DB data. And obviously we have Dockroot. Dockroot is our code base. We're mounting our code base as well. And the fourth volume that we have here is our config. Our config is the configuration sync directory of Drupal. So when we're running drush config export, it will be stored here, and it will. We're making sure that it's part of our repository because that's how we want to transfer our config changes from one environment to another to the other environment. We are trying to use configs like drush config, so that's why we are mounting our configuration as a volume as well. So that's the 4 volumes that we are mounting for our Docker Compose, and both are like the first 2 are from web server, the other 2 are from MySQL database containers. Okay, moving along, so just to give you a general idea of our branch structure, our Git branch structure, we have 3 branches. One is dev, the second one is staging, and the last one is master. So our dev branch is for our development. So any change, whenever there is a change to our dev branch, we trigger a build task on Jenkins that will build the development environment. And we have staging. Our staging branch is again for staging environment. So whenever there is a change, so nobody has to go there and start the build. The build will automatically start whenever there is a change on our staging branch. The third branch that we have is our master. So the master branch is where we have our production environments. But for production environment, we don't actually do automated build. We have the task, but somebody has to come in and start the build. The build for our production is a manual build. So that's kind of the structure that we have when it comes to a Git branch. So if we discuss if that's our local environment, how does our hosting environment looks like? So we obviously choose Amazon Web Service to host our for our deployment. The reason that we choose Amazon Web Service is like it provides a secure hosting, and it's also very scalable. And the other thing that because we work for federal governments, something that we really care is it compliance with federal government? Is it FedRAMP certified? That's really, we care about that. And as long as you follow the guideline from Amazon Web Service, AWS is compliance with federal government, and it's FedRAMP certified. And also, the other thing is it's pay as you go. You don't have to pay in advance, nothing in advance. You just pay for what you used. That's another reason that we choose AWS. And finally, it has great set of tools. I think I have heard during their last reInvent, they introduced around 1,600 services. AWS is really growing very, very fast, and they have really pretty cool services that you can use. So like Route 53, their DNS service, and they have CloudFront for CDN, and they have CloudWatch for monitoring. And because of those great tools, we go with we are going with AWS. So what we did with AWS is we just spinned up an EC2 instance. So for this specific demo, we are just sticking to the free tier eligible instances, which are T-micro. So we just spinned up 2 EC2 instances. So sorry. As you can see, we have we spinned up 2 instances here for our demo tool. Thank you. So spinning up an instance on AWS is very straightforward and easy to do. If you have AWS account, you can just go ahead and launch an instance here. You can easily launch an instance. So just you can choose any of the operating system. You can select operating system from image provided by AWS. You can also import your own image if you have an image. You can also use contributed image from AWS community. So we're just going with Amazon Linux, which is CentOS-based image. So once we select that, this is the instance type. This is where we choose the instance type. When choosing the instance type, if you're kind of checking it out, just testing it out, make sure to stay with on free tier eligible instance type, which is T-micro, and then it will give you 1 GB RAM, and you can have up to 30 GB SSD hard disk, which is, I believe, enough for testing it out. Then the next is configuration. We don't need to change anything. Just make sure that here we have auto assign public IP address enabled, because we are going to need that to access our instance. And following that, this is the storage section, and here you can tag your instance. Just give it a name, department, because this will help you kind of identify what the service of this instance is. Like, give it a name here, and and so the whole reason that I go through this process is to reach here, the configure security group. As I explained earlier, our container runs on specific port number. Like our dev runs on one specific port number, and our staging container runs on a different port number, and our productions container runs on a specific port number. And AWS allows only SSH connection by default. It only allows port number 22 to be accessed by default. If you want to add custom ports, you have to add the custom ports on the security group. So for us, like our dev container is accessed on 8989, and you can select the CIDR range here, but we are going to remain from everywhere. So the CIDR range is where you limit the access. Like, for example, if you want to limit the access to your development instance from specific IP address range, you can provide the IP address range here. But for this demo purpose, I'm going to set the CIDR range from everywhere. And means this port number will be accessed from everywhere. So just keep adding those ports that you want to make available for people to access on your EC2 instance using your public IP address. So then you can review the instance and launch it. So when we launch, AWS gives us 2 options. The first option is we can generate a new private key. So this private key is going to be used to access our server using SSH. We can also use an existing SSH key if this is not our first time spinning up an EC2 instance. We can use an existing key. But if it's our if it's our first time spinning up an instance, we can we can come here and say create a new key pair, and AWS will let you download just one time. If you lost that key, then you have to kill the instance and restart again. So you can give it a name and download the key pair. We are going to use this key pair when we integrate our EC2 instance with our Jenkins installation. So just make sure to keep this somewhere safe. So this is how we spin up our EC2 instance. And once we spin up our EC2 instance, the only thing that we need on our EC2 instance is Docker. We just need to install Docker and Docker Compose. We don't need Apache, we don't need PHP, we don't need anything else. We just need Docker and Docker Compose, because all of our application, our PHP, Apache is going to run on a container. So the only thing that we need on our container, on our EC2 instance, is to have Docker and Docker Compose available. So then we just install Docker and Docker Compose. For this demo purpose, I have already spinned up an instance and installed Docker, and I will show you guys how we are going to access that later. And so I mentioned that the only thing that we need on our EC2 instance is Docker. And for us, we have additional instance that we install Nginx on. So Nginx is what we use to reroute requests to the appropriate container. So our container will run on a specific port. Like, for example, we have a domain called govcondev.desferal.com. This needs to be mapped to our development container. So our development container will have an IP address and a specific port number. So because we don't have Nginx installed, we don't have Apache on our EC2 instance, what we did is we spinned up another EC2 instance and installed Nginx on it. So on our Nginx configuration, we mapped the correct domain name to the correct container instance. So if someone wants to access govcondev.desferal.com, we map it to the correct IP address and the correct port number of our development container instance. So in that case, we can forward the request to the appropriate container. So that's how we did it. So one thing to mention here is you don't really need to have another EC2 instance. You can do it on the EC2 instance that you spinned up for Docker, because this is just a simple configuration. This is a very simple thing that you need for to introduce a front server in front of your containers to forward the request to the appropriate container. I'll do this. I'll demo this later. So that's our hosting. We have talked about our local environment, which is just simple Docker installation, and we have talked about our hosting, which is going to be an EC2 instance on AWS. And the next part that we are going to discuss is our automation. So basically, if we have only these two, if we have our Docker and our EC2, what we have to do is like either we need to have Git installed on an EC2 instance and pull the change from specific branch, or we have to do a manual deployment, like just SCP the changes to our EC2 instance and run Docker on servers again. But what we did is in our case is we introduced another automation server called Jenkins. I'm not sure if you guys are familiar with Jenkins. So Jenkins is an open source automation server where you can automate deployment. And it works great with EC2 and GitHub and also it works great with SVN. If anyone is interested with SVN, it works great with it works great with Windows Server as well, but for our case, we're sticking only with EC2 instance and GitHub. So it works great with GitHub and EC2 instance. The only thing that you need on top of the default installation is we need to have two plugins installed on the server. The first one is Publish SSH, and the second one is GitHub plugin. So Publish over SSH will help us add an SSH server on our Jenkins thing. So now Jenkins needs to do two things. One is deploy changes to EC2 instance or SSH server, and the other thing is get changes from GitHub. So we need to get change from GitHub. Jenkins needs to have a permission to pull data from our Git repository and deploy changes to EC2 instance. So in order to have that functionality, in order to make Jenkins be able to deploy changes to an EC2 instance, we need to provide a authentication mechanism on Jenkins onto our EC2 instance. So the way we did this is we used a plugin called Publish over SSH, and we just added our SSH server on Jenkins. So this is how we add our SSH server to Jenkins. For the host name, you can have either the public IP address of your EC2 instance, or if you have a domain name, you can also use a domain name. And username, the default username for, if it is Ubuntu installation, it's Ubuntu. And if it is CentOS installation, EC2 will give a default username, EC2 minus user. You can use that username, or you can create a new username as well. And here comes the previous key that we talked about, the private key that we talked about. And we need to provide the key here. So now what we're doing is we're just adding a new server, a new EC2 instance server on Jenkins. Once we did that, now Jenkins will be able to deploy changes to this EC2 instance, because we have given we set the host name or the IP address, and we configured the username, and we also configured the private key. Now Jenkins will be able to deploy changes to an EC2 instance. So now once we make sure that Jenkins is able to deploy changes to EC2 instance, the next thing that we need to do is we need to ensure that Jenkins is able to get data from our repository. We need to make sure that we need to ensure that Jenkins can go out to our Git repo, get the changes, and deploy the changes to EC2 instance. So the next thing that we are going to do is add a credential, GitHub credential on our Jenkins. Again, it's just adding an authentication mechanism on GitHub to go on Jenkins to go out to GitHub and get the change from our repository. So there are two ways to do that. You can provide your just normal username and password, GitHub normal username and password. You can configure that as a credential. You can add a credential here on GitHub and provide username and password. But if you think that's security threat, you don't want to give out your username and password of GitHub, what you could do is you can generate a token on GitHub, a personal token on GitHub. So you don't have to provide the username and password. You can just generate if you go to GitHub developer setting, you can easily generate a token. So you can specifically mention the scope for that specific token. You can say that this token, anyone who is using this token can see my repo status and can report deployment, and also can execute admin repo hook. You can specify the scope for that personal token that you've generated. So once you generate that personal token, you can configure that personal token as a credential on our Jenkins, on your Jenkins installation. So now Jenkins will have a credential to go out to GitHub and get changes from. So now we have the two things that we need. Jenkins can deploy changes to EC2 instance. Jenkins can get changes from GitHub repository. So that's the two things that we need. So now we have our Jenkins ready to deploy. We have our Jenkins ready to get data from our repository. This is how we did it. So as you can see there, we have 3 branches. One is dev, the second one is staging, that's the third one is production, which is our master branch. And we have a build task for each branches. Like whenever there is a change on dev branch, the build task will be triggered. The build task for dev will be triggered. And whenever we have a change on staging, the build task for staging will be triggered. But on production, even though there is a change on master, we don't trigger the build task automatically. Somebody has to come in and run the build task. And the way we configured, so something that I need to mention here is our Jenkins is installed internally. So I'm connected to our VPN, and I'll show you guys how our Jenkins installation looks like. So we cannot send a Git hook trigger from GitHub to our Jenkins installation. What we did is we configured our Jenkins to do polling every minute to check if there is a change on a specific branch. If there is a change on dev branch, Jenkins will automatically start building and deploy the change to EC2 instance. These are the 3 build tasks that we have on our Jenkins. We have a build task for Drupal GovCon dev. We have a build task for Drupal GovCon production. We have a build task for Drupal GovCon staging. So these are the 3 build tasks that we have created for our deployment. So I'll try to explain, just go over our build task for development. So here we are configuring where our source code is coming from. What are we using our source? Where is Jenkins getting the source code from? So this is the first thing that you see here. We are configuring the repository URL, and we are using the credential that we created earlier to pull data from our source code, from this specific repository. Once we get that, so the branch that we are building on this task is development. So we don't care if there's a chain on master, we don't care if there's a chain on staging, on any other development branch. The only branch that we care on this build task is our dev branch. So if there is any chain on dev branch, this build task will be triggered. And the way we are triggering our build task is here we have a poll that runs every minute. So every minute we're running a poll to check if there is a chain on our dev branch, on this specific branch. If there is a chain on that specific branch, Jenkins will start building, and we'll see the Jenkins will start building and deploy the chain to our EC2 instance. So here is the catch. As we explained earlier, we have environmental variables for our local development, which defines environmental variable for dev, environmental variable for staging, environmental variable for our local and production. So during our deployment, what we are doing here is, because this is our development deployment, we are making sure that we are using the correct environmental file for development, and we are also making sure that we are using the correct Docker Compose file for development. So I'm not sure if you guys can see this. Can you see this, guys? No, right? So I'll put this on our README file of our repository, so you can see it. So what we are doing is, like, we're executing a bash script to replace our environment variable with the environment variable that we created for development, and we are also replace Docker Compose file with the Docker Compose file that we created specifically for this environment, which is currently our dev environment. So this is doing like CP copy the development the dev version of Docker Compose to Docker Compose file, and also copy the environment file of development to be the default environment file. So then we then run Docker Compose build. This will build the environment specifically for our development environment. So this is a trick that we use to pass a parameter of to specifically mention which environment that we are building on, we're building for. So if I explain that, let's just do a quick demo. So I'm on my local now. This is my local environment. As you can see, I have so I have a Drupal site running on port number 9090. This is our local. So our local container is running for Drupal site is running on port number 9090. So if I access localhost 9090, this will bring up my local environment of Drupal site container. So if we do this quickly, localhost 9090. So this is pulling data from our local our local Drupal site container. So as you can see, I'm using localhost, which is the host IP address. I can also use the host local IP address, which is probably like the IP address that I get from the wireless, and I'll pin the port number 990. That also will bring our development container. So what I'm going to do is like I will try to add a content type here and do Drush export and commit our change to Git and see how Jenkins will start building and log into our EC2 instance, try to import configuration and see the change on our development instance. So let's do that quickly. Content type, add a content type here. Let's just call it Drupal GovCon events. So I don't need to add any fields. I'll keep it simple. It will have title and body, and save. So now we added a content type called Drupal GovCon events. So if we come to our Docker directory and do Docker, so this is, if we do Docker PS, we can see which containers are running here. So the container that we care about is Drupal side, because we have Drush installed on Drupal side. This is where we install, where we have Drush and Composer. So if I do Docker execute interactively, in this one, Drush config export. So I'm now executing Drush on Drupal side.
Oh, just by breadcrumbs.
Sorry guys. Yeah, I think that container was right there. That was my assumption. Let's try to log into
Space.
home. Huh.
Sync. Inside contact. Do RMPIR and then config.
Let's do it on staging, on our staging. Check out. Okay. Stage.
Just take your go to your sync directory. Pull it out here and go to your sync directory. Create just a copy from here. Open on the terminal and open it here on the screen. Do ls and see if your directories. Do the config and create some directories here.
Yes.
And then give rights to the edit it. Give rights to edit it. Select one. Config. And now try to run it.
So, yeah. The config export is not working. What I'm going to do is I'm going to install a module and push the module to our remote repository. All right. Okay. So here we have our docker directory. Doc roots, and if we do modules, yeah, we have our modules directory here. So we have our modules directory here, and if I try to just download one module from Drupal.org, Drupal.org. So let's just try to download the module and see it as it goes to download.
Just a drush download. Do drush to download.
Okay, that's good. So yeah. Drush. DL, do you have any module? Devil. Yes. All right. Okay. Sorry, guys. I will make sure to share the repo, and for some reason the demo is not working. And I think let's try to open the floor for question and answer and quickly wrap up this.
The reason you use the time polling versus on commit.
Yeah. So
the question is, why are we using time polling instead of token?
yeah. So the reason that we use time polling is because our Jenkins is installed internally. There is no connection from GitHub to our internal GitHub. But definitely that's the way to go. It's all right. Thank you, guys. Appreciate it.